Hello, and welcome to our session. This is a presentation about the SUSE Manager Hub for large-scale environments. Today, we're going to cover the SUSE Manager Hub overview, the deployment architecture or options to do so, centralized management components, and a small demo. I'm Anne-Marie Batrinca. I'm one of the technology consultants at SUSE.
And I'm Ricardo Mateus, and I'm a software engineer at SUSE Manager Development Team. So, starting with the SUSE Manager Hub overview, SUSE Manager is designed to be used as a single server and is able to scale up to 10,000 clients with one single SUSE Manager server. However, we are getting requests to be able to manage larger and larger deployments and be able to cope with a much bigger number than 10,000 clients at the same time with a single installation. So that brings us to the problem on how can SUSE Manager scale? How can we be able to cope with these kind of requirements and manage even larger environments with several clients at the same time? So to do that, we need to be able to scale horizontally. And instead of having one SUSE Manager server, we plan to have several SUSE Manager servers to manage this kind of large-scale environments. But this also brings the problem that we need to be able to manage these SUSE Manager servers that are deployed. And to do that, we will be using a SUSE Manager server on top of this infrastructure. So basically, we'll have a SUSE Manager server that will manage other SUSE Manager servers in the deployment. But we need to name this server. So we named the top SUSE Manager server as a hub server, and the down SUSE Manager servers as peripheral servers. So we can have to distinguish between which SUSE Manager servers in this deployment architecture are we talking about. But this SUSE Manager Hub is more than just a couple of terms. It's like an umbrella term for all the scalability efforts that we are doing in the SUSE Manager world. And one of these terms is the Hub Architecture, which is basically a deployment blueprint that allow us to support big scale environments. Other concept is the Hub Server, as I explained before, which can be defined as a server of servers, and is the central piece of this architecture, and is composed of a SUSE Manager server, but also a set of tools that were developed to allow us to manage this kind of peripheral servers.
For the deployment architecture, we will take in consideration a series of questions during the architecture and design phase. First of all, we'll have to do some environment discovery, asking how many endpoints, what products and Linux flavors and architectures are in the environment, what type of physical locations and network layout the customer has. We will also need to decide how many peripheral servers we need, and that is going to depend on the amount of endpoints. We try to map around 6,000 to 7,000 endpoints per peripheral, because even though one SUSE manager can manage up to 10,000 endpoints, we need to leave some space for growth. We will also have to decide where to place the various peripherals within the environment or that network topology. There are questions around a proxy versus a peripheral. When do we use a proxy versus when we use a peripheral? So as we've explained, the peripheral allows us to scale up the amount of endpoints that we can manage, whereas a proxy is going to reduce and relay some of the load of downloading patches and updates through a subserver that is registered through a SUSE manager or a peripheral. So the proxy just reduces load, but it will not increase the amount of endpoints that we can manage. And then we also want to plan for onboarding automation, identify naming conventions, logical mappings, and which endpoints are going to be registered to which peripherals ahead of time. And if that can be programmatically identified, it will help with automating that registration later on. For the network topologies, there are a few variations. You can have an internal network with peripherals that manage minions or minions and proxies. You can have, like example for the peripheral number 3, a peripheral that manages proxies at various retail locations. Or you can have, like peripheral 4 on the right-hand side of this diagram, a remote network and a peripheral located across the ocean, managing different minions and proxies in that area. There are some hub and peripheral installation considerations for the for hardware, some requirements, some minimum requirements that may differ from the SUSE Manager documentation. Specifically for hardware, there are the minimum requirements for CPUs is 4, and for the minimum RAM is 32 gigs. We would recommend for the hub 8 dedicated 64-bit cores and 64 gigs of RAM because we're going to be exporting and importing data. And the export is, of course, going to use more resources. For the SUSE Manager peripherals, we have found that for the most part, the documentation minimum requirements might work. But if you wanted to work faster on the import of products, then you could also increase the CPU and memory there. For the file system layout, specifically the database, varlib, pgsql, that database file system, its minimum required is 50 gigabytes. Of course, it does depend on how many products or how many various operating systems you have in your environment that you need to manage, but increasing it to 100 gigabytes for the hub and for the peripherals is going to help with that import and export as well. There are some additional packages that are required for the hub: the inter-server sync, the hub XML RPC API, and the UUnit config modules and config formulas, which Ricardo is going to talk about later. And on the peripheral, we just need the inter-server sync. That is just going to help us import the products. File share might be helpful, like such as an NFS mount that could be connected to the hub and peripherals, so that when we export all the data and we import, we don't have to copy it over to each individual peripheral server, which would take quite some time. And in terms of configuration and for automation, it's better to keep the main organization name and the SUSE Manager admin and password the same for your hub and peripherals. This will help later on. There are also some deployment considerations for the proxies and the minions. The proxies and endpoints are not going to be seen in the hub dashboard or the web UI on the hub. Only peripherals are going to be seen and registered to the hub, which means that all the activation keys, all the system groups that you want to create in Bootstrap repositories do not need to be created on the hub. Those need to be created on your peripherals for registration. Any proprietary salt states that you create on each peripheral may need to be replicated on all the other peripherals. So that needs to be thought of. Either you check them into GitHub and copy them down to every peripheral, or you find some other way to do that. There are questions about, should we automate proxy deployment? If you just have a few corporate proxies, then that might not be necessary. But if you have proxies or branch servers at various retail locations and they're all cookie cutter and there are thousands of them, then it might help to automate the proxy deployment. And should we automate the minion registration, especially with hub environments, because there will be tens of thousands, if not 20,000 or more endpoints, then minion registration would probably be automated, right? And that needs to be planned out ahead of time. As a first step to the deployment architecture high-level flow, there are the components on the SUSE Manager Hub, just like on any other SUSE Manager, that can be used to create a clone of the system that we just installed, the hub, using YAST. We can use YAST clone system that will generate an auto-inst XML file. We can place it using the CLI in srv www htdocs pub on our hub, edit the IP address and host name, and use this information together with the auto-installable distributions that have to be created in the web UI to deploy 1, 2, or however many peripherals we might need to. And this will be a sequential exercise. And at this point, the peripherals servers would be spun up. They would have the same file system layout and sizing as our hub does, but SUSE Manager will not be installed or configured just yet.
Okay, so so many SUSE Manager servers brings us the problem of how we can centralize the management of all these servers. So the first thing that we think about is, okay, if we have a hub and several peripheral servers, we will want to centralize the management of organizations, for example, or even the users or client or system groups at high level, and also activation keys. To be able to do this, we develop a set of salt modules and salt states and formulas to allow us to manage this directly from the hub, to manage organizations and trust between organizations, users, system groups, activation keys. And these states are defined on the hub level, and we can apply these states to each of the peripheral servers in a parallel way. And here you can see an example of how this salt state looks like. So we have the salt state name uni.group present. Uni is the upstream project of SUSE Manager. And you can see that the name of the group will be httpd_servers. And all the systems that have httpd on their name will be assigned to this group. For this to be able to apply to the peripheral server, we need to also define the organ administration user and password, so we can be able to create this system and assign all this, create this group and assign all the systems to this group. Another thing that we need to also manage in a centralized way is the content of our deployment architecture. So we're talking about software channels, configuration channels, or even images. And you want to synchronize only the hub with SEC products, for example. And in this case, you want to synchronize SLE15 SP2 or SP3. And then you want to move this content to each of the peripherals and have some coherence between all the peripherals with all the content that needs to be deployed. To do that, we develop a new version of the inter-server synchronization for SUSE Manager, and this is basically a command line tool that allows us to export content from one SUSE Manager, that is the source SUSE Manager server, and import that content to a target SUSE Manager server. These import and export concepts are independent from the hub architecture, so you can install this tool in a SUSE Manager server. We can export the desired channels or software channels or configuration channels or even images, and import it to the target server, which could also be used in air-gapped environments to transfer content between SUSE managers. Currently, this process is not automated, so users need to SSH into the SUSE Manager source server, run the command line tool that will save all this data to the file system, then copy that file system, that files to the target server, and run the import command. However, Anne-Marie will show you how it was automated and can be automated to copy all this content across SUSE Manager servers.
Okay, so for the rest of the picture of the deployment architecture, when you take all of the other components that sit on the hub, like Space CMD, the salt pillars and the states, the UUnit config modules and formulas that Ricardo has talked about, and the inter-server sync v2, we can use these tools, some of the existing and some of the new tools, to install SUSE Manager on our peripherals and configure all of the peripherals in parallel. And that will be explained further in the demo. For our demo, we will have 4 steps. In step 1, there will be a peripheral deployment example with AutoInstXML. This has to be done sequentially on each peripheral. For step 2, we'll have peripheral setup using SALT, installing SUSE Manager and making our initial organization and first user. For step 3, we will use ISS v2 on our hub to export one product and on our peripheral to import one product. For step 4, we have peripheral configuration, creating users, system groups, and activation keys on peripherals with SALT and the uuniconfig modules that Ricardo has spoken about. For step 1, I already have a lab hub called KSUMA that I've previously configured. On it, I have created a auto installation distribution with the base channel of SLE product SUSE Manager 4.2 pool. And using YAST clone system, I have already generated the auto inst XMLs for the 2 peripherals I want. The only difference between these 2 would be the hostname and IP addresses inside the auto inst XML. And these will give the installer a full description of what packages need to be installed and how to configure it. And we will start our setup. So I will create a new machine. I still need my ISO. I'll provide it with resources. And a name. Since I already had peripheral 2 and 4 set up, I will be doing 3 and 5. When I get to installation, I will just pass the URL of our AutoInstXML. And this will start our installation. Now, this installation in my labs takes about 10 minutes. When it is completely set up, it will be a server without SUSE Manager installed. We will do that in step 2. We'll come back when this is done. Our installation is now done, and in the meantime, I've also deployed the second peripheral, KSUMA BB3. It brings us to the login screen here, and our next step would be to bootstrap these peripherals to our SUSE Manager Hub. And I'll use the web UI to do it. Now this system is bootstrapped. It's going to appear here shortly in our systems list. And there it is. And we'll bootstrap KSUMA BB5 as well. And once these systems are bootstrapped, we can install SUSE Manager as our next step using our salt states. Now on our hub server, I have created a folder called SRV Salt Peripherals. And the first two states that we want to run from it are the install Suma state. And I'll just show you this code quickly. It has some logic to identify if SUSE Manager was already installed, such that we don't redo it. Pushes down an environment or setup environment.sh file with some information in it, and then runs the SUSE Manager setup and validates the services are up. And I've also made a make first user and org state that will ensure that the web services are up, and then create the first user and organization and the user's password. It is important to keep the organization name consistent, as well as the org user across your hub and peripherals for future steps in automation. And I have also included both of these states in a full setup state. So I will run that together against both of these peripherals right now. I'm just going to ping them first to see that they're up. And then state.apply peripherals.full setup. Now the states do take a little bit of time to run, but it is installing all the SUSE Manager components on our two peripherals in parallel. Our installation has completed on one of the two peripherals. And this is our output. And we're waiting for our second peripheral to complete. And it has also succeeded on the second peripheral. Once our salt states have completed, we can go to the URL of our KSUMA BB3. And we should be able to log in with our SUMA admin and password that we had in our salt state, and we are able to do so. At this point, however, we're not going to have any software channels like we do on our hub, because we need to import and export some. For the inter-server sync component, we will need to know what our base channels are. So I've used base CMD software channel list base channels to list those. That includes SUSE product as well as any content lifecycle management we've created. We should also have the inter-server sync product or package installed on our server, which we already do. And it comes with some help. So we can export a channel with children, an individual channel, and also packages only after a certain date, which will mean that our very first export will be a very large one, but subsequent exports can be deltas. And for the purposes of our example, I will just do one channel, and that is the proxy pool. Provide an output directory. and run the export. Now this should take just a few seconds because I know that there are only 3 packages in this channel. And then when it is complete, we can look at the contents of this folder. It will contain 4 files, actually 1 folder and 3 files. And this would have to be synced over to each peripheral or have an NFS mount available such that the peripherals can see these directories, and then we can run the import on the peripheral end. So the import is going to be very similar to the way we did the export. We just have to provide the import directory location, and then those packages will be imported into our database and visible. The channels will become visible in our web UI. Now I have already run my import against my peripheral 3. And if I click on software in the web UI, then the SUSE Manager Proxy pool and 3 packages it contains are now visible. As our step 4, we will create system groups, users, and activation keys on our peripherals. This has to occur after we've exported the products from our hub and imported them to the peripheral, because the activation keys do make reference to the channels that we want to create them for. So we have an example of a system group for proxy servers. Notice that we do pass the org admin user and password that is consistent across, or that was created before as our main org admin. I make my own user, and then I create an activation key just for the SUSE Manager Proxy base channel with the 3 packages that we've included. You can also add child channels here once you've imported and exported the full product. And I have created a combined state that will include the system groups, users, and activation keys all in one. And I'm going to run it against our 2 peripherals. I'm just going to run it with a test is equal to true first. Now, because this is using the UUnit configuration module, you may get this error. And you can either refresh module or apply the high state on to your endpoints. So we could just do the high state. It's faster or easier to remember. And now that that's done, that will also refresh the modules. So we can go back and test our full config. And then we can run our full config. And as a final validation, after we've run our full config, we can validate that our user was created under users. Here it is. Under systems, our system group was created, proxy servers, and under activation keys, we have our SUSE Manager Proxy activation key that we created, all using the UUnit configuration modules. And this concludes our demo. Thank you.